Good morning, Dr. Grissom. This is going to be for Project 2, for Phase 2. And let's just get into it. So, obviously, we have to include all our libraries. The first thing new that maybe we're going to include is the weather images, which again we use for Project 1, and then we have to have our raw I2C communication for both sensors, which is going to be the sensors that we're using are the VNCL 4040 and the SHT 4040. The next thing we're going to do is we're going to have to add a third screen like we did for Project 1, which is going to be our local screen. And then after that, we're going to do our string bitmap calling to our open weather, which again we did. API key is the same as last project, my Wi-Fi information. And then we're going to have our timing variables, which is 5,000 milliseconds and 5 seconds. And then we're going to have the internet weather update timer, pretty simple. Then local SHT 40 screen will have to update every 5 seconds, not too little, not too much. And then it will read that actual proximity light sensor for more frequently, so the LCD reacts quickly if it if it dims or turns off. And then here's our LCD variables. Again, Fahrenheit just like Celsius, just like the Boolean project. The only thing is making it one button in this time. And then it stores that brightness for the ambient light reading, which again we had 120 in the original project, so I just kept it like that. Zip code variable, same thing. Internet variable, same thing. Pacific Daylight. Then we have our separate timestamp, and then our I2 pins for those sensor addresses, the SHT default one, and then the high precision humidity one, and then the I2 address. Then we define those registers and the actual values of those temperatures. And then we started the values forced from the local screen draw, the actual VNCL 4040, and then it starts to calibrate through 300 and 220. So the unsigned integers right there, right? Then we have our ambient light max at that, and then it prevents tiny light changes from constantly changing to LCD brightness. Then after that, we have our method header declaration, and again these are just our original project ones, so we're not going to go over that. Then screen and navigation method, which we need as always, and then we have our raw I2C helper methods just like previous work. Then of course we need our sensor methods, and then after that we have our automatic LCD control methods. And then it runs once, initiate we talked about. I2B bus needs to be both for the SHT4 and the VLC40. They need to work simultaneously because they are both at different addresses. And then we have our main loop running always, and then it was including the zip screen, which why we needed to put the code here. And then the proximity controls where the LCD is off, and then the ambient light controls the brightness if the LCD is on. And then let's see, original zip, again that's fine, nothing there. And then the temperature unit button, which now we have button A do that. And then our screen navigation, which the B will do the internet weather and the local weather, which this will switch to the local weather. And then it will update through the open weather API, right? And then we do the SHT40 screen updates because we want to have it up to date, and then to navigate all around again. And then after that, we draw that complete local weather on that screen. And then we identify this as the local sensor page, the live readings, the title and prominent values, and then the humidity, and then button directions, timestamp, all that. And then we redraw only the timestamp area back onto the local state. And then we'll read and update that SHT40 every 5 seconds. Then after that, we save the exact time and then have the sensor read it. Then it compares the value from the previous one, which is a 0.1 threshold, which prevents us from our floating point noise. Again, we're going to use an Adafruit library. So this had to exist where it sends a 1 byte high precision measurement command to another, and then it sends all these bytes, which I have commented out just so we understand how it works here with the code. Then you check both CRC bytes, so your corrupted sensor data is rejected, and then it converts that raw 16-bit reading using an SHT40 datasheet, which was provided. And then the actual calculation, which I needed AI's help with because I did not know how to do that part. And then to initiate the VNCL 4040 or the raw I2C right, and then to enable the proximity sensing and the ambient light mode, and then it reads those actual values finally. And then after that, this turns off the LCD based on pretty much, which again was copied from the assignment because we did turn off the light and on, so I could just use most of that code. Then dim and brighten the LCD basically. And then we did the raw I squared C helper functions. Then just these are the original Project 1 methods, all being reused for those zip screens, and that will be about it. So basically, if you can see down there, is detecting the temperature, the brightness, the ambient light, which is the white, and then the proximity. And then the temperature is displayed on screen here. That I can also show you, which there will be a video of me demonstrating what is fully happening. I think that wraps it up. This was a lot of code, but a lot of it I could copy from the previous assignments for phase 2 and phase 1. So, and just rework a couple variable names and stuff like that. So, I think that wraps it up. And then there will be, again, a separate video of me demonstrating the actual device working. All right, thank you.